Hello everyone, welcome back to the session. A very good evening first of all. Yes, 1 second. Yes, okay. Now listen to carefully. Uh, Today we'll be having 2 hours of session, okay, and after that, basically, we'll finish off with entire data science. Okay, so first thing that we're going to learn is understanding the visualization using Seaborn library. Now, whatever we have done in the previous class, that was simply the basic in the sense we have learned matplotlib, right? So that was basically the basic of understanding the visualization. But in today's class we'll understand with the actual data set how to import or how to display any values or any data with the help of Seaborn library. Yes, just give me a minute. Now, uh, first thing that we're going to do is import the pandas. Okay, import pandas as PD, as well as import the data frame is equal to pd.read_csv file. And I think already you have the CSV file, that is nba.csv, right? So let us go through with nba.csv itself. So if you don't have the data set, I'll quickly send that data set in the chat box, don't worry. But before that, let us upload the data set in the chat box, I mean the file. Yeah, nba. Okay, it has been uploaded. Now I'll send that in the chat box. Yes, I've sent you in the chat box, just check. And finally, just run the df. Now this is the output you're supposed to get. Okay, you can see there are 457 rows and basically 9 columns. Now once you get this data, I think already analysis has been done with this particular data. But today we'll understand with how to do the analysis with the help of visualization. Visualization in the sense using the line plot or in the using scatter plot, using pie chart, all those. First thing that we're going to learn is understanding the line plot. Here, first thing that I'm going to do is you are supposed to import the library name. So just now we have understood how to import the pandas, right? You can see import pandas as PD. Now, just like this, we have to import Seaborn as well. So to import Seaborn as well, you are supposed to write import Seaborn as SNS. Now, this is a short form of basically alias name of the Seaborn. And after this, along with it, you have to import the matplotlib as well. So matplotlib dot pyplot as a PLT. Okay, so this is the primary thing that is supposed to do. First of all, import the Seaborn as SNS. Import matplotlib.pyplot as PLT. Now, if you ask me why exactly we are using matplotlib inside the Seaborn, I'll tell you why. Okay, first thing that you're going to do is first you are writing the SNS or basically alias name, and along with it you are using a plot name that is a line plot. And after this, you have again in the line plot you have x-axis as well as the y-axis, but in the matplotlib what you have done, we have used x-axis and y-axis and we have written it manually. Can you see this? We have written it manually. But now what we'll do is we will put that with the help of data frame, or basically let us get that value with the help of a series. X is equal to, let us access one particular column, that is, let's say age column. Okay, now the x-axis basically will be having the age. Give a comma, now give a y column or the y parameter. Here, let us give the value as weight. Okay, let's run it. But if you run it, you can see, yes, are able to see, this is the output we are able to get, and this is quite advanced when you compare to the matplotlib, right? In matplotlib we used to get a very simple line graph, but here we have a line graph where we have the lowest value of that particular data, we have the highest value of that particular data, and also we have the average value. Now this is the representation of this line plot. Okay, so whatever you can see this, I mean it is light shaded blue. Now this is considered as a very low value of this, let's say 38 or 39 years. This is the highest weight, that is of the 38 or 39 years, and this is the average weight. Okay, now I told you why we are exactly using this matplotlib. See, if you see the output, you can see axis, that axis is given, that is x label and age, y label is weight is been given, or it is been printed in the output. Now I don't want to print this as the output, I just want to see my graph. So in these cases you are basically writing plt.show function name to basically eliminate all those things that unnecessarily printed in the output. So you can see this output as the complete output that we want to see actually. Is that clear? Any doubts? Okay. Let's move on to the next one. That is the scatter plot. DF means data frame. I think if you have not used or not understood this, kindly go back to the data science part and understand the data frame first. Otherwise, you'll not understand here. And one thing, let's say I have to create, I mean, whatever we have done is a little bit advanced when you compare to Matplotlib. Let's say I want more advanced than this. For example, let's say I want for each position, I want to check their weights. Okay, we have something called as position right here. Can you see this position? So for each position, let's say I want to have to, I mean, I want to check their age according to their weight. So to do that, you are using something called as hue, HUE, and in that you are supposed to mention the position. Now if you do that, you can see the same exact graph, but line graph has been changed. You can see we have one, two, three, four, five different line graphs, and inside that you have something called as this position, and it is saying which line is which. In the sense, you can see the position C that is here. So I can say that whoever is in the position C have basically higher weight, and whoever is there in the PG basically they are tend to have this lower weight. Okay, this gives a better idea when we compare to the previous matplotlib. Correct? Yes. Why is this shade? I told you, right? It is from this particular data. This main line is the average line. Okay, main line is the average line. But if it has more than one value, so this will be the lowest value. This will be the highest value of that particular age. Okay. Next, we will understand the next one where we will write the same thing, that is import cbon. Okay, you don't have to write it again and again, but it's a good habit to write it. Okay, so import cbon as SNS, import matplotlib dot pyplot as a plt, SNS dot line plot. Again we are using line plot, and here let me mention x is equal to df of position. Now I mean the x-axis I want the position, and in the y-axis let's say I want the age. Okay, so x-axis everything here will get the position, and according to the position we have the age. Let's see. So we'll use plt.show. Okay, can you see the output here where you can see PG we have the lowest value as 26, we have the highest value around 27.5, and middle and between 27.5 and 28. SF we have the same value, around same value. SG we have the lower value when we compare to the other position. PF is greater than all of these values, and C is the greatest value. So basically, whoever is playing in C will be having more experience, I can say, right? Any doubts, still on? Okay, we'll move on to the next plot that is called as the scatter plot. Now, also we have learned this in the matplotlib, so we'll do the same thing here. SNS dot scatter plot And here we'll mention the X value as age, or the X axis as age, and Y value, let me mention it as, let's say, weight. Okay, let's run it. Okay, so this is the output you're able to get. If you see the output, you are not able to understand what type of data this is, or you're not able to understand the data properly, or you're not able to understand the visualization properly. So the solution for this is you can either put a category. For example, I told you how to mention a category. So hue is a term where you can mention the category based on what you can mention the visualization. So I want the category called as a position. Okay, and if you run it, now you can see according to the position we have the scatter plot. Now if you have, I mean, if you're basically doing the same thing with the help of line plot, I think that is better. But we are understanding the scatter plot. That's the reason I have given you. So you can see most of the values in the top are in the purple, or basically it is a position C. So I can say the weight of the players who are in the position C have the greater weight, and whoever is there in this PG position, or basically this blue dot, correct, have tend to have the lower weight. Correct. Next, we'll understand the box plot now. Now, in the box plot, always we are supposed to give only one data. One data in the sense we are supposed to give only one column. We cannot mention two columns, that is X and Y. We are supposed to mention only one column, or one particular data. So here, let us mention SNS dot box plot, correct? And inside that, you have to mention, let's say I told you we are supposed to give only one value. So I'll give one value as age. Let's see. Can you see? This is our output, where we have the highest value uh, around 40. We have the lowest value below 19. And this is the most of the players. Okay. This whatever box you can see here. This is the actually the entire, I mean, if you see the entire data, this is the most of the players' age. And whatever you can see this is the average age. Okay. I think it is between I think it's 26, right? 25 and 30, and it is having this line here. So it is around 26. So I can say most of the players is having the age of 26, but they are between 25 to 30. In the sense, most of the players, correct? So this is the understanding of box plot. Let's move on to the next one. We have to understand something called as pair plot. Now, this is a very interesting plot, which is generally not being used in the analysis. This is understanding, I mean, this is very much important when we have to understand the, let's say, description of the data set. For example, you can see if I use a function called as describe, okay, if you use this, you have something called as number, age, height in inches, weight, and salary, and you have mean, standard deviation, minimum, maximum. All these things are there, right? So you can see we have the minimum value, we have the maximum value, we have the average value. Everything is being described here. Just like that, inside Seaborn, we have the same description. Okay, but it is providing you with the help of a plot. And what type of plot this is? This plot is actually called as pair plot. Okay, SNS dot pair plot, and here you are supposed to mention the entire data frame. Okay, just like you are mentioning df dot describe, just like that you are mentioning the entire data frame here. And also, let's say I want the category. Again, I'll put the category as position, so I'll mention position here. Okay, and let's say I want the title of the graph, so I'll mention plt dot title, and I'll mention pair plot as, sorry, pair plot of NBA data, and plt dot show to display the graph. So it will take some time because it will be having more than one data, or more than one particular graph. Okay, you can see this is the output we are able to get. Correct. So we have the age column, we have the height in inches column, we have the weight column, we have the salary column. So most of the things which basically have the data type of float or int, such kind of things are, or such kind of data types are basically taken, and such kind of data has been visualized. Okay. but most of the time it doesn't make any sense. You can see age is there. Okay, sometimes it makes sense, but most of the time it doesn't make any sense. So I highly recommend you're not supposed to use this. Okay, this is only used when we have only number data type, or let's say float data type or integer data type. But most of the time it doesn't make any sense. So most of the time we are not supposed to use this. Okay, I think that's it for that's it for the SNS, or basically the CBON. I'll repeat it once again. Whoever is having the doubts. So previous class we have understood the matplotlib. I'll quickly show you from the beginning. Yes. So digital visualization, we have understood the different types of charts, that is box plot, pie chart, line chart, and the scatter plot. This is how you basically used to do it, right? Import matplotlib dot pie plot as PLT, and you have given the x-axis and the y-axis inside the PLT dot plot. Now this is where you are supposed to run it, and this is how you used to get the output. Just like this, instead of writing the data manually, or basically writing instead of writing the x-axis as well as y-axis manually, what you're doing now is giving the directly the column name, but you're changing the library to something called as cbon library. Okay, you can see import cbon as sns, but instead of matplotlib you're using import cbon as sns, and you're calling the sns dot line plot. Okay, just like you have used plt.line plot or plt.plot to understand the line plot, here you're using sns.line plot and giving the x-axis, that is df of age, or basically the column name. Exactly like that, we have given the y-axis, that is df of weight, again a column name. And what is this hue? Hue is a category. Okay, according to the category, if I want to see the visualization, then we are mentioning something called as HUE. And according to the category I told you is the position category. Now this is the output you are able to get. This is a line plot. This is a box. I mean, sorry. This is a scatter plot. This is a box plot, and this is the pair plot. Now there are different plots to be understood. If you want to explore more, you can just Google it out. You are able to understand it more. I think if you do it by yourself, it is better so that you can understand it better. Okay. Yes. Any doubts now? SNS is a Seaborn library. Just like matplotlib, you can see matplotlib.pyplot as we have used PLT, right? This exactly same thing we are using as SNS. SNS means seaborn. Okay. Hue means a category. Okay. According to the category, if I want to see the output, then we are using something called as HUE. Or basically, I can mention this as like this. HUE is nothing but category. So according to the category, if I want to see the output, I'm mentioning HUE. Now you don't have to worry about this. Okay, you don't have to worry about this because all this are very advanced level data science. Okay, so if you are understanding only so much, okay, that is the. Let me just quickly show you. Yes. So if you're understanding so much, that is understanding with the help of group by function, based on the question, if you're able to create some answers, or based on the question, if you're doing some analysis, if you're understanding so much, it is well and good. Okay, if you don't know or do not understand the matplotlib or the cbon, it is not a worry. You have to understand the cbon as well as the matplotlib if you're completely into data science. Okay, if you're understanding only the basics of data science, only the pandas as well as the numpy is very much important. If you're understanding that, it is well and enough. Okay. Yes. So now I request everyone to do one thing. Now, whatever we have done till now, this is completely basics of data science. I told you, right? Now we are starting with machine learning now. Okay, we are starting with machine learning. So one thing you can do is you can create a new file. Okay, click on this file and click on new notebook in Drive. So that you can have the difference between the data science as well as the machine learning. But if you're doing in the same, what is that? Yes. If you're doing the same thing, or basically if you're using the same collab link for the machine learning also, it's your choice. I don't mind, but it is good to have the separate file. Okay, if you're doing Yeah, if you are doing the data science and the machine learning together, it's fine. But please make sure you are creating a new file after that. Because once you are complete with it, you are supposed to submit your data science file, you are supposed to submit your machine learning file, as well as you are supposed to submit your AI file. Okay. So I want everyone to create a new file. And once you're complete with that, I want everyone to give a thumbs up in the chat box. You're supposed to create a new file. Just click on this file and click on new notebook in Drive. So it will keep on, basically it will create a new file. So once you have created a new file, kindly give a thumbs up in the chat box. Okay. Yes, very good. Now, uh, first thing that you're going to write is right here. Okay, done, right? Okay, give me a minute. Yes. So the data I'm going to send right now is very important. So it is called as a spam email data set. Okay, I'll quickly send that. I want everyone to download it. Okay, it's called as mail underscore data dot CSV file. So I want everyone to download this. And once you have downloaded, I want everyone to give a thumbs up. Yes, done. Yes, you are supposed to now import the collab. Okay, import the data set into the collaboratory. So click on the file, click on the file, upload file, and click on the mail data that you have just downloaded. This is a very interesting concept. So I want everyone to give a proper attention here. Okay. So it is called as a mail underscore data. So kindly upload it. So once it has been uploaded, now I want everyone to listen properly. First thing that we are understanding with the machine learning concept is the workflow of it. In the sense, how does it work? So let me write here something called as workflow of scikit learn. Now, what is the meaning of this scikit learn? Scikit learn is basically the library that is being used, or basically the library that is used for understanding the machine learning concepts. Okay, whatever you do in the machine learning concepts, the scikit-learn is a primary library that you go to. Okay, first thing that you're understanding is the workflow. Let us understand the workflow. We have basically five different steps that we are supposed to go through. The first step is to understand, or basically the setting up the data. I want everyone to write this: setting up the data. Okay, one, I'm setting up the data in the sense, just now whatever we have done. For example, you have uploaded the file, you have uploaded a file called as mail data.csv, and setting up the data in the sense you're basically cleaning the data. For example, I'll write here import pandas as a pd, and we are writing a data frame is equal to pd dot read underscore csv, and you're mentioning the name of the file, that is mail underscore data dot csv. Run it. Okay, so this is the output you're able to get. We have only two columns. One is called as category, one is called as a message. Very simple. Now from this, let's say if you have anything, okay, if you have anything that is particularly uh, null values, okay, whenever you're understanding the machine learning concepts, your data, okay, it should be very clean. Very clean in the sense you shouldn't be having any null values, you shouldn't be having any no duplicate values. All the things should be very much clean. So to understand that, you are basically using the is null function, and we are checking whether we are having any null values or not. So let's check. Okay, it is saying category is 0, message as 0. Now we again do not know whether we are having any duplicate values. For example, if you just see this data frame, we have some duplicate values here. Can you see the spam? I mean, last rows. We have spam, we have click on this link to win lottery, click on this win to win lottery. So basically, this is considered as a duplicate values, right? So we are not supposed to have this duplicate values. But as of now, since we are understanding the basics of machine learning, we are just ignoring it. But usually, if you have duplicate values, you are supposed to treat it. And this comes under a setting up the data step. Okay. If you're having, if you're having the null values, if you're having the duplicate values, you are supposed to remove that in the first step. Now, once the first step has been completed, now we are moving on to the second step where you are basically creating model. Okay, there are several models that we have to learn. I think most of the models that we are going to learn is very much simple to understand, but there are some models that is very complicated. But as of now, we are not learning that, because since we are understanding basics, I don't want to stress too much of models into your head. So this is how you basically, basically the second step, this is how you basically create a model. Once you have created the model, next thing you're doing is training the model. Okay, once you're importing the model or once you're creating the model, whatever data we have, that data has been given to the model and that is been trained. Okay, once it is been trained, next thing that you're going to is the testing the model. Okay, so first thing that you're going to do is basically setting up the data, that is understanding whether we are having null values or not, or the duplicate values. If your data is very much clean, then we are starting with the creating the model. Once the model has been created, now we are giving the data so that we can train the model. And once it is trained, now the step is to test the model. Can you tell me what happens, or what is the fifth step of the scikit-learn or any machine learning model? Everything has been completed now: setting up the data, creating the model, training the model, testing the model. So what might be the fifth step? Exactly, we are supposed to deploy the model, right? Or basically we are supposed to deploy in such a way that in the future it is able to predict by itself. So can I say the fifth step is prediction, right? So whatever data we have given to it, it is able to predict it based on the output. Now let us come back to our data set. Now we have two columns. One is called as a category. One is called as a message. Now, how many of you understand? How many of you used Gmail or basically any mailing services? I Yes, everyone has used it, right? Very simple it is. So you are getting different mails in your Gmail or let's say Outlook or anything like that, and there is something called as a spam folder. Yes or no? We have something called as a spam folder. And what do you think the spam folder is actually? Can anyone specify what do you mean by that spam folder? Okay, why the spam folder is there, or why it is present there? Okay, you can say ads are there. Okay, what else? What else? What else are there in the spam folder? Repeated mails. Okay, what else? So can I say yes? Promotions. Very good. So can I say the spam files, or basically the spam folder, is containing such mails which the Gmail or the Outlook will understand or will think that it is not required to the user. Yes or no? It is unwanted mails, I can say. So basically, spam is considered as an unwanted mail. And what about the good mails, or basically what about the important mails? Now, the important mails in terms is called as a ham email. Okay. So unwanted mails is called as a spam email, and the required mails are basically considered as a ham email. Now, these are the two categories we are understanding. Now we are creating a program, or basically we are creating a machine learning model where it will understand the text that you're going to give. Okay, it will understand the text that you're going to give, and according to the text, it will predict whether the given data is, or given mail is, a ham email or a spam email. Okay, so let us begin. The first thing that you're going to do is understanding the first step, that is setting up the data. So I want everyone to set up the data in your system. It's very simple, just like you're importing the pandas as well as you're importing the data frame, just like that you're supposed to do it. So start with importing important libraries. The first thing you're going to do is import numpy. Okay, we have to import three libraries. One is the numpy, one is the pandas, import pandas as pd, and the last one is import sklearn. Okay, this is called as a scikit-learn. I told you, right? This is called as a scikit-learn, but separately do it. So first thing I'm going to do is import the important libraries. That is two of the libraries. One is numpy as well as the pandas. Okay, run it. Once that has been run, next thing that you're going to do is importing the model. Importing the model. Okay, can you tell me what type of model? Okay, what type of model are we supposed to use here? But before that, what I'll do is I'll just print, or basically I'll just show you the data. If I just click on this nb.csv mail data, right? 1 second. Yes, everybody can see this mail data.csv. Now we have two columns here, right? We have one column called as category, one we have called as message. Now this is basically the two columns that we have. Now from these two columns, what are the two categories you can see? I want everyone to reply, because these things are very much important. I want everyone to reply. What are the two categories you can see here? Okay, everyone is saying ham and spam, right? Yes or no? So ham is one of the categories, spam is one of the category. Okay. What do you mean by spam category? I just now told you it is considered as a junk emails, or basically it is considered as the unwanted emails. But what about ham emails? Ham emails is considered as an imported mail, right? Yes. Now we have something called as message here, right? We have the category that we have understood, and we have something called as a message. Now, if you're giving any data, okay, if you're giving any message, what are the two possible outcomes? One is ham and one more is spam. So basically we have only two categories, yes or no? So can I say we have the binary category? We have binary category, yes. So what do you mean by binary category? Binary category means we have only two categories, or basically whenever you're dealing with only two outputs, these are considered as a binary category. Whenever we have binary category, then we are using a very important model called as logistic regression model. Okay, I'll repeat. Whenever you're having two categories, or whenever you're having binary categories, then we have something called as logistic regression model to be used. Okay, very important. This is whenever you see the two outputs, okay, then you should consider the logistic regression, because this is a model which works perfectly with the help of two categories. whenever you are dealing with two categories, this will work perfectly. So that is the reason. Okay, so let us import it. So to import, you are writing from sklearn dot linear underscore model. Now this you're obviously you're supposed to by heart, because there is no option to understand this. You have to understand from where you're getting this particular model. So you're getting the model from the sklearn, that is the main library. Now from the main library, you have a sub library called as linear model. Now from the linear model, you are supposed to import the logistic regression. And also, when you write the logistic regression, the R should be capital. Okay. So let's run it. Okay. Once it has been done, now let us. I'll just write a comment where binary output. So binary output in the sense we have only two outputs, right? Okay. After this, I told you we are supposed to. Okay. Once we have created a model, I told you we are supposed to train and test the model. Okay. So to train and test the model, we require one particular library. So let us write that importing train test split function. So what is the meaning of this? See, this particular function basically will split the data into training data as well as the testing data. So that is the reason it is called as train test split function. Okay. So to get this data or get this library, you are again writing from sklearn, because I told you sklearn is a library which is basically dealing with the machine learning. So whatever machine learning concepts is there, you are supposed to get it from the sklearn. Okay. So from the sklearn, you are getting a model selection. And from the model selection, you are importing something called as train underscore test underscore split function. Okay. Run this and run this as well. Okay. Let's move on to the next one. Now we are supposed to import a very important function called as accuracy function. Import accuracy function. So what is the meaning of this accuracy function? See, accuracy function in the sense, let's say you have given some data. For example, if you have given some message called as hello, how are you? Okay, this is the message you have given to the system. Okay, first thing that you're going to tell is whether it is a ham email or whether it is a spam email just by looking at this mail. Can you just categorize whether it is a spam email or a ham email? Is it a spam email? Hello, how are you? I want everyone to reply in the chat box. Hello, how are you? Whether it is considered as a ham email or a spam email. Again, I'll repeat, ham means a valid email or a imported email. Spam means it is unwanted email. Okay, everyone is saying ham, correct? Okay, so you're writing ham email. Okay, now we know that it should be considered as a ham email, but if the system by mistakenly it is categorizing it as a spam email, okay, it is categorized it as a spam email. That means it is not being trained properly. Okay, it is not being trained properly. And how do we get to know that whether it is trained properly or not being trained properly? That is done by using the accuracy score. That means it is, let's say, if I mention hello, how are you? And it is perfectly giving me the output as ham email. That means we have the higher accuracy score. For example, the accuracy score is 90%. Let's say, okay, we have the higher accuracy score. But if I have this accuracy score that is less than 50%, that means there's a high possibility that it might be giving me the ham output or it might be giving me the spam output. It is 50-50. Whenever we are having the accuracy score that is more than 90%, only then we are supposed to go to the next step. Okay, so in the training the model, we are supposed to check this accuracy data. Okay, we are supposed to check the accuracy score. Only then we can move on to the testing. Okay, only if the training model or a training data set will be having more than, let's say, 80% accuracy score, only then we are supposed to go for the testing of the model. Otherwise we are not supposed to go. So to do that, or to find the accuracy score, we have a very important library called as from sklearn once again dot metrics. Okay, import accuracy score. Let's run it. So this is the accuracy score function. So everything looks great. Now what we'll do is, now we'll start with the data set. Okay, now one more function we are supposed to write, but I'll tell you later why we are supposed to do that. So let us start with importing the data set. Okay, first thing that I'm going to do is I'll write a data set as mail data itself. Mail data is equal to, we are calling the pandas, that is pd dot read underscore csv, and you're giving the name of the file, that is mail underscore data underscore dot csv, and run the mail data and check whether you're getting the output. Yes, I want everyone to reply in the chat box whether you're getting this output, that is category and message. I want everyone to mention yes in the chat box if you're getting this output, that is category and message, or basically display of data frame. Are you getting it? Kindly write yes in the chat box. Okay, very good. Now, first thing that I told you, first step is to basically set up the data. So what do you mean by setting up the data? Setting up the data is to understand whether we are having any null values or not. How to check whether we are having any null values? That is by using the isNull function, right? So isNull function, and make use of the sum function and run it. So you can see category, we don't have any null values. Message also, we don't have any null values. Now this is a function that we are using for the data science. Okay, from the data science, we have adapted this particular function. So that is the reason we have to understand the data science first. Then only we can move on to the machine learning. Now, whatever concept we are learning in the machine learning, now these concepts are implemented in AI. So that is the reason we are understanding data science first, then machine learning, then it is AI. We cannot go in a backwards way. That is AI, then the machine learning, then data science. No, we have to understand data science, that which basically has the core of everything. Then we are going to machine learning, then we are going to AI. Okay, so we are understanding that there is no null values. Okay, once we are understanding that there is no null values, what is the next step? Next step is to basically create the model, right? So to create the model, what you're going to do is come to the new cell. Okay, uh okay, before creating a new model, before creating the model, or before yeah before going to the second step, let's do some basic analysis that we have learned in data science. Okay, so let me write here basic analysis. So let's say I want to check how many ham emails are there in my data set and how many spam emails are there in my data set. Can anybody tell me how can we do this? I want to check how many ham emails are there in my data set and how many spam emails are there in my data set. How can I do that? So if I run the data frame, or sorry, the mail data, very good, very good. If I run the mail data, yes, you can see we have two columns, that is category and message. Now, which is the column we are supposed to access first of all? We have to access the category column, right? So let us access the category column. Let's run it. Okay, now we have the category column where we have ham and spam. Now, out of this, we have to find how many ham emails are there and how many spam emails are there. So what I'm supposed to do? We have to use a value counts function. Very good. Value underscore counts function to get this output. Okay, can you see the ham email? We have 4,825 and spam email is 1,742. And also, you can see it is not in the single row. So let us mention a reset index to get the value in the single row. Okay, so this is the output we are supposed to get. So this is the basic output or basic analysis that we have done in the using the data science. Okay, now let us move on to the creating the model. But before creating the model, we have to understand something. We are not yet done with this setting of the data. Now, I told you setting up the data means we have to remove the null values as well as the duplicate values, but it is not just that. It is more than that. Okay, so to understand this, we are mentioning something called as label encoding. What do you mean by this? Okay, I'll ask a very simple question. Okay, of a computer. What is the language, or what does a computer understand? It understands only two things. Can you tell me? Yes. So basically, it is binary. That is, binary means 0 and 1, right? So what is binary? Can I say 0 and 1 is a numbers? Correct. So whenever it is a numbers, or whenever it is 0 and 1, basically, now it is able to understand. But if I give the data, or if I give the machine this, okay, that is ham and spam, or basically these type of words, is it able to understand? Obviously not. Okay. Whatever you have written or whatever is been written in the very simple English format, the machine is not able to understand. So the primary thing that you're going to do is you have to change this ham and spam into numbers. Okay. So the simple thing that you can do is wherever you can see ham, can I say I'll change that to 0? Or let's say ham, let's say change that to 1, and spam, I'll change that to 0. Okay. So once we are converted into 0 and 1, so category column has been converted properly. But what about message? But before that, let us first of all do it for category. So to do that, we are using something called as right here. Uh, Okay. So we have, I mean, we are supposed to label the spam email as 0 and ham email as 1. So to do that, we are using a location function. Now we have understood already location function in the data science, right? So inside that, what is the first thing that you're accessing? You're accessing the rows. But here, you are accessing the column directly. Okay. That is mail underscore data, and you're accessing the category column. Okay. And you're writing a condition where you are accessing directly the ham values. Okay, so basically, in the place of rows, you are mentioning a condition where mail data category is equal to ham. So if I run it, you can see we are getting only the ham values. Correct? We are not getting any spam values. We are getting only the ham values. And from here, you are supposed to change that to the given value, that is 1. Correct? We are supposed to change the ham values into 1. So what you're going to do is give a comma. Give a comma. Now, what column we are supposed to change? We are supposed to change the category column. So mention category column and directly write or directly equate this into 1. Okay. Same exact thing you are supposed to copy, come to the next line, paste it. But what are we supposed to change here? We are supposed to change that to spam, and we are supposed to change that to 0. So let's run it. Okay, perfectly running. Let's go on to the next cell. Let's check whether we are getting the output correctly. Okay, can you see everything has been converted into 0 and 1 now? Okay, we don't have to mention in place is equal to true because we have directly given the values into 1 and 0, so we don't have to do it. Okay, so mail data in this, you can see category has been converted into 1 and 0 now. What is the second step, or basically, what is the next step? Okay, what is the next step? Next step is to understand or basically separate the value into something called as input feature as well as the label. First of all, I'll write it, then I'll explain. I'll write here separating the mail data into input feature and label. Okay, what is the meaning of this? Please understand, this is very important. I'll quickly give a recap of what we have done till now. We have we have 5 steps of scikit-learn. That is setting up the data, creating the model, training the model, testing the model, and prediction. As of now, we have not completed with setting up the data because 2, 3, 4, 5 is exactly same for everything. Okay, every single model we are using the same 2, 3, 4, 5 steps. But for the first step, it is always different. Okay, it is always different. So that is the reason I'm telling you understanding the setting of the data is very much important when before understanding this 2, 3, 4, 5 steps. Okay, so in the first step we have understood we have to import the models, import in libraries also, and after that we have to suppose check whether we are having any null values. If not, then we are moving on to the basic analysis of the data set. Then if we have categories, we are supposed to change that to a numerical data type so that the machine is able to understand it. Okay. So till now we have understood so much. Now I think it's a good time to tell you the something called as separating the mail data into input feature as well as the label category. So what's the meaning of this? So to understand this, we have something called as X as well as Y. So X means always input feature. Okay, and X means input feature. Y means it is label. Now, please understand, I'll equate this and then will understand with the help of an example. So imagine you have built a system. Okay, imagine you have built a system. Let's say you have built a machine learning system. Now, what is the primary work of this machine learning system? Can anybody tell me? So imagine you have built a system with the help of this data set. Now, if any other users come to your what is that? Let's say website, they have to. I mean, what are they supposed to give to you? What are they supposed to give to you in the sense? What is the input value they are supposed to give so that you are basically giving you the output? What is the input you are asking from the user? Yes, exactly. You are asking the message from the user, correct? So, messages, let's say, hello, how are you? Now, this is a message that is being given by the user, yes or no? This is a message that is being given by the user. What is your task or what is a machine's task? Machine's task is to basically understand the output, okay, or basically give the output, yes or no? So, output is nothing but ham or spam, or basically, can I say prediction by the machine, right? So what is this prediction by the machine? Can I say the prediction of the by the machine is done according to the category? Yes. So can I say prediction of by the machine is nothing but the category column? And hello, how are you? Can I say this is coming from the message column? Again, I'll repeat. This is very important. I told you. We have something called as input feature as well as the label. Input feature is nothing but the user has to give the input values so that the label is being predicted by the machine. So input feature, we have given the message that is, hello, how are you? Now this will be given to the machine, and the output or basically the label, right? That is nothing but the prediction by the machine. That is nothing but the category column. Yes or no? We have something called as zeros and ones. That is the category column, and that is been predicted by the machine. So input feature are those values where the values has been given by the user, and label is nothing but the values given by the machine as an output. So in this case, what is considered as a input feature? What is considered as input feature? Anybody? I want everyone to reply. Be quick. Yes. Uh, yes. Hello. How are you? Basically, the message column. Can I say it is the input feature, right? So you're accessing mail data, and you're accessing a particular column that is a message column. But what about Y column? Y column, I told you this has to be predicted by the machine. Label is a term that is being predicted by the machine, and that column is category, correct? So from the mail data, you are getting only the category column. Okay, so we have understood the X and Y. Let's run it. So much is clear. Now we'll just print it out, print the X value as well as the Y value to check whether we are getting the correct output or not. So print X, that means we are getting the input data here, or input feature, and we are printing the Y to check whether we are getting the label. Okay, we are perfectly getting that is ones and zeros, and here we are getting the entire message. Perfect. So till now, whatever we have done, is that very much clear? Any doubts till now? Any doubts till now? I'll be giving you 15 minutes break from 7 o'clock to 7:15. I'll be giving you the break. Until then, I want everyone to go back and understand whatever we have done till now. Okay. I'll be giving you 15 minutes breaks from 7 to 7:15. Sharp at 7:15, we'll come back and finish off this particular uh, machine learning model. Okay. Yes. Hello. Yes, welcome back. Now, those who have joined right now, I think you have not able to understand what we have done here. Basically, we have started with machine learning concepts. Okay. Quickly, I'll just recap what we have done because I cannot again explain it because just go back to the recording classes, you are able to understand it. But we'll try to create one more session where you are understanding some of the basics now. So, machine learning concepts we were started with, where I told you we have basically 5 steps. Okay, the 5 primary steps. One is called as, I mean, the first step is basically called as setting up the data. Setting up the data in the sense we have to understand whether we are in our data set we are having any null values or not, whether we are having any duplicate values or not, or whether we are having any unwanted emails or unwanted mail data which is not required in our training data set. So that is considered as setting up the data. Okay, well, not really so much. Don't worry. We have. I told you setting up the data means removing the null values and removing the duplicate values. Understand only so much right now. Next, once setting up the data has been completed, now we are creating the model. Now there are different models, and according to the situation or according to the data, we have to create the model that we require. We think that is required in our data set, or we think that is required in our machine learning model. Next, we have something called as training the model. Okay, training the model in the sense basically once the model has been created, obviously we are supposed to train that model. Once the training has been done, then we are supposed to test the model. And once the testing the model has been done, or basically we are getting the good accuracy score, then we can move on to the prediction. Now this is the primary workflow of the scikit-learn, or basically the machine learning models. That is first thing, setting up the data, creating the model, training the model, testing the model, as well as the prediction. Now we have some important libraries that we are supposed to import. First thing that you're importing is NumPy as NP and Pandas as PD. I think this we already know, correct? My voice is low. Okay, 1 minute. You're able to hear, right? But it is very low. Okay, 1 second. What about now? Now is this fine? Yes, okay. I'll repeat once again whatever we have done till now. We have 5 steps: setting up the data, creating the model, training the model, testing the model, as well as prediction. First step is nothing but once you get the data, you are basically removing the null values, if any, and if you're I mean, basically you're removing the duplicate values. Okay. Once everything has been cleaned up, then you're basically creating the model, then training the model, testing the model, and finally the prediction. Now this is the workflow of the machine learning in, I mean, any machine learning model. Okay, and any machine learning model requires a very important library called as scikit. Okay, this is called as scikit-learn, and generally it is called as sklearn. That is the meaning of scikit-learn. But before that, we are importing the important libraries. We require two libraries here. That is, one is NumPy as well as one is pandas, that we already know. Next, we are importing the logistic regression model. Now, why? If you ask me why exactly we are uh, uh, importing this logistic regression model, see, if I open the data set, if you don't have the data set, kindly let me know in the chat box. I'll just okay, I'll upload it once again. This is called as mail data.csv file. Okay, I've sent you in the chat box. Just check. Now, if I just open it, you can see the output here, or basically you can see the data set. We have two columns. One is called as category, one is called as message. Okay, and in the category we have ham as well as spam. Ham means it is a what is that, important emails, and spam means is considered as a unwanted emails. Okay, simple. We have two categories, one is ham and one is spam. Ham means wanted emails, spam means unwanted emails. Now whenever we are having only two outputs, or basically whenever we are having any two categories, then only we are using logistic regression model. I think this is very much clear. Next, once we are understanding that, we have to import something called as train test split function. Why exactly? This function is basically used to divide the data set into training data set as well as the testing data set. Okay, that's the reason it is present here. After this, we have something called as accuracy score function. Now, why is this particular function is being used? Again, it is used to check what is the accuracy score of the training data. Okay, once it is predicting the training data, we are supposed to check whether how good it is, right? For example, if I give a very simple mail call as hello, how are you, can you tell me what it is supposed to categorize it as? This particular email, what my machine is supposed to categorize, it is supposed to categorize it as ham, right? So this category, whatever it is done, let's say it is converting it as a spam email, that means our accuracy score is not so good. If it is converting into ham email, that means our accuracy score is very much good. So that is the reason you are getting the correct output. If you're getting the wrong output, that means your accuracy score or whatever you have done the training, that is not accurate. So once the accuracy score function we have understanding, then we are basically importing the data set. Then we have put in something called as mail data, and we have checked whether we are having any null values or not. That is the first step. Okay, that is the first step. Then we have done some basic analysis where we have found out how many ham and spam emails are there. Then we have moved on to this label encoding. What do you mean by this label encoding? See, whenever you open any website, okay, any website, in this website, okay, let's say you are creating a website where if you go to that website and if you enter a simple email, it has to convert into ham or spam based on the email that you have provided. So can I say this input feature? Yes, input feature, or basically whatever message has been given by the user. Can I consider it as an input feature, or can I say is the input given by the user? Yes. So in this case, what is the input? Input is the message, correct? What about the output? Output is basically the category. But before understanding the category, or before understanding whether it is a ham or a spam, machine doesn't understand words, or machine doesn't understand letters. That is the reason we have converted ham into 1 and spam into 0. Okay, so if you run the mail data here, I'll go to the next cell and write it mail data. So if you see this, we have converted mail data into zeros and ones now. So you can see zeros and ones. But what about message? Now, whoever has been part of the session from the previous hour, I till now I have mentioned everything now. But soon after this, what are we supposed to do? Soon after this, what are we supposed to do? Now, what we're going to do is we are splitting the data into training as well as the testing data. Okay, training and testing data. So how to convert it? First thing, please note, this is very important, and this is very much applicable for everything. Okay, every single model we are using the same thing. We have 4 variables that you have to mention. One is called as x train. Okay, x train, why we are using? Because x is nothing but your input feature. Okay, from this input feature, I mean, we are taking the input feature and we are training the model, so it is considered as x train. Then we have something called as x test. Now, same X value or same X input feature is taken for the testing also. So that is the reason we have two variables, X train as well as X test. Now, if I have X train as well as X test, don't we have Y train and Y test? Yes, we have Y train as well as the Y test also. Okay. After this, after this, basically what you're going to do is you are calling the train test split function. You're calling train underscore test underscore split function. So that you can, okay, if I mention this mail data in a separate cell, yes, if I consider this mail data in a separate cell, you can see we have 6,567 rows. So can I say this is 100% data? Correct? Can I say this entire thing, whatever we have right now, can I say it's 100% data? Yes. So from this 100% data, let's say 80% of the data, I'm converting it to as a training data because we require more data to be as a training data and a small part of the data to be a testing data. So train test split function, inside that you are mentioning two of the things, that is one is X as well as Y. That means the input feature as well as the target column or basically the label column. After that, you are giving a parameter called as test size. And for timing, I'll be mentioning this test size as 0.2. Okay. What is the meaning of this 0.2? 0.2 means 20% of the data has been converted into a testing data. Okay. Again, I'll repeat. If we mention 0.2, that means 20% of the data is converted into a testing data. Okay. What about training data now? If 20% is considered as a testing data, what do you think is been converted into a training data? How many percentage has been converted into a training data? Exactly, it is 80%. Correct? So let's run it. Okay, it is running. Now to check whether it is converted into 80% as well as 20%, we are supposed to check with the help of one function that is called as shape function. Now, why exactly shape function is used? Shape function is used to check how many number of rows and how many number of columns we have. So you can see X is one of the input feature and it has only one column. So that is the reason we have 6,567. That means rows we have. Then after this, if I mention X train dot shape, what exactly I'm expecting here? What exactly I'm expecting if I run this X train dot shape? So this training data should be having 80% data. So out of 6,567, 80% should be the output. Let's see. Can you see? We are getting 5253. That means 80% of the data. What about if I want to check for the 20% data? Then you're writing for y test dot shape or y train dot shape. Anything is fine. Both are exactly same thing. Y train dot shape and run it. Can you see? Okay, okay, training data. I'm sorry. We have to mention testing model. Yes, y test dot shape. Okay, can you see 1314? Okay, 1314 is basically 20% data. So 6567 is 100% data. Out of 100% data, 80% is the training data, that is 5253, and 20% data is 1314. So that is the meaning of this test size is equal to 2. Test size in the sense, whatever testing data is there is converted into 20% data, and rest of the data has been converted into training data. Okay, next. After this, let's convert, or basically let's transforming the text data. Now, this is very, very, very important. Data feature into numeric machine understanding data. Okay. Transforming the text data to text data to, yes, transforming the text data into numeric machine understanding data. Now, what is the meaning of this? See, if I run the X, that is your input feature, you can see we have all letters or basically words. Does these letters or words is able to, the machine is able to understand? Does the machine understand all these? Okay, okay, I'll explain once again. Don't worry. This train test split function is nothing but the main objective of this is training data we have to consider it as 80%, and testing data we have to consider it as 20%. Okay, 20% out of the entire data set we are taking as the testing data, and 80% we are considering it as the training data. So to do this, you are writing first four variables. Okay, it is not mandatory to mention 80 and 20%, but it is mandatory to give higher number of data to higher number of data to as a training data, and little bit lower number to as a testing data, because we require more values to be in the training data. That's the reason. Okay, always this should be basically greater than the testing data. It is not necessary as it is 80% and 20%. It can be 90 and 10 also. It can be 70 and 30 also. But the output might be different. Okay, as the training data is increasing, okay, as you're giving more and more training data and lesser the testing data, it is good for your model. That's the reason. Yes, exactly, accuracy increases. So we have four variables here: x train, x test, y train, y test. So what it will do is it is basically splitting the data into 80%, that is training data, 20% into testing data. So whatever this x test and y test is there, it is having 20% data, and y train and x train is there, it is having 80% data. That is the meaning of this train test split function. No, we cannot mention 100% data because we have to test it. Without testing it, we cannot move forward. Okay, we have to test at least 99, 1% also we are supposed to give it as the testing data. It has to be given. But usually we consider as 80 and 20. Okay, usually we consider as 80 and 20. Okay, now I'll come back to this. I'll come back to this where we have something called as message. Now, in this message, you have some letters written, we have some words written. Now, the primary question I'm going to ask you is whether these words, whatever is there, is understandable by the machine. Obviously not, right? So, to convert, we are supposed to convert these letters or words into numeric format. Okay. Why we are converting into a numeric format? So that the machine is able to understand it. So to do that, we have an important library that we have to mention in the beginning. Okay. In the beginning only we are supposed to mention it. So let me mention it here. Wherever you have imported the important libraries, after the accuracy score, let us create one more. And here, let me write here to convert all the strings, or basically all the string format into numeric format. Why? Because so that the machine is able to understand it. So from sklearn dot feature underscore extraction dot text import. Now this is a very tricky library name. It is called as TFID. Okay, TFID F vectorizer. Okay, this is called as feature extraction. Sklearn dot feature extraction. What you are extracting, basically you're extracting the text, and the imported library is called as TFID F vectorizer, and run it. Once you have run it, now come back to the previous one. Wherever you have written the last thing, where you're converting the data into the numeric machine understanding data. Now here, what you're supposed to do is you are supposed to call the feature extraction. Okay, kindly call the feature extraction. Now instead of X, let me call feature underscore extraction is equal to. Now we are calling the library name. So what's the library name? The library name is TFID F vectorizer, and we should be capital. Okay, and there are some parameters that you're supposed to give here. The first parameter is given as minimum DF. Okay, minimum DF in the sense it has to be, at least one data frame has to be present inside this feature extraction. Otherwise, it will not run. Okay, TFID vectorizer. Okay. Yes. So minimum DF is nothing but minimum one data frame should be there inside your X value. Otherwise, it will not run. So that is the meaning of minimum DF. After that, what language is this? Can anyone tell me what language is this? Obviously, it is English, right? So English, we are supposed to give it as stop words. That means we are giving the machine, we are saying that all this, whatever words is there, these are the English words. Okay. And also you can see some of the values are capital letter, some of the values are small letter. So what we'll do is we'll convert everything into smaller case itself. Better. Okay. We'll convert everything into smaller case. Let's run it. Okay, perfectly running. Now we'll move on to the next step where we are whatever this X train and X test is there, right? X train and sorry, X train and Y train is there. If I just print it out, if I just print it out, you can see it is all mentioned in the letters and words. Let's convert this into a numeric format. So to convert into a numeric format, let me give a new variable called as X train num. Will extract the feature extraction, and we are basically fitting the data. Okay, we are fitting and we are transforming. So fit underscore transform is given, and what we are fitting, basically we are fitting based on the training data. Same exact thing you are supposed to do, but one single changes is there. Now here it is instead of x train num, here we have x test num, right? X test num here we have, and instead of fit underscore transform here, we are not supposed to mention fit underscore transform. We are supposed to mention only transform. Okay, we are supposed to mention only transform, and instead of x train, we are supposed to mention x test. Let's run it. Perfectly running. Now we'll check the x train num as well as x test num. Let's see. Okay, can you see? It is been converted into a float 64 now. Correct? You can see Sparks matrix of data type is float 64. So it has been compressed. Same thing, let us mention for x test num. Okay, again, you can see it has been converted into a numeric format, that is the float 64. Now, if you get this output, that means it is being converted into a numeric data. Okay. Now we'll move on to the last step. Okay, this is a very interesting steps, and it is basically used for every single what is that models. Okay, so let me write here training the model, training the model. Okay. So in the training the model, first thing you're going to do is you are calling the model. What is our model name? Logistic regression, right? So let us call the logistic regression. Don't worry if you are not understanding. I'll repeat it once again. I'll make a separate session for this, because whatever we have done till now, I think most of them were not available in the previous class. So that is the reason you are not able to understand right now. So what I'll do is tomorrow while coming to the next class, I'll repeat it once again, all the steps. Okay, don't worry. But as of now, just understand it. Okay, whatever we are doing the steps. So let's run it. So model has been imported. After this, we'll get the training. I mean, basically, we'll train the logistic regression model. Okay, we'll train the logistic regression model with the training data. Okay. So first thing you're gonna do is you're calling the model and you're using a function called as fit. And what you're fitting two of the things. One is the X train num, as well as you're putting the Y train. Okay, basically all the training data, whatever we have, that value you are supposed to put it here. X train underscore num, and as well as the Y train. These two things you are supposed to put it inside the logistic regression. Okay, X train num. Okay, something's wrong. Y train is why we are getting this output. One second. Unknown label type. Fit to a classifier. Okay. Actually, it is correct. Now, why we are getting this? Okay, this is very uh okay, okay. I'm sorry. I'm sorry. We have to convert. Okay, I'm sorry. I'm really sorry. We have missed one step. Uh After doing this, extrain. Yes, we have to. Okay, we have converted the extrain numeric value, and the testing value has been converted into numeric value. But we have not converted the y train as well as y test as the as I mean basically we have not converted into an integer. So to do that, we'll write here convert y train and y test values as integers. So we'll call the y train first of all. Will equate to y train. Okay. I taught you something. Okay, I taught you something where you are supposed to convert any data type into whatever data type you want. Can you tell me what is that function name? Can anybody tell me if I want to convert exactly? Very good. It is as type, right? Very good. So inside that, let me mention int as the data type that I want to convert. And same thing, we'll do it for y test is equal to uh, y test dot as type. And here, let me again convert into integer. Let's run it. Now we'll run the model. Now we'll run the, yes, now we are getting it. Okay. So if you're getting this output, that means the logistic regression has been, it has been fitted with the training data. So once it has been fitted into a training data, now we can evaluate the training model. Evaluate the training model in the sense we are checking what is the accuracy score. So evaluating the trained model. So to check the evaluation of the train model, what we'll do is we'll first of all call the X train prediction. Okay, we'll call the X train value and we'll call the model and we'll try to predict it first of all. Okay, and predict based on what? Based on the X training numeric. Based on the training data, basically we are finding the prediction. And whatever this prediction value is there, that prediction value's accuracy score we are supposed to get it. My voice is still very low. No, right? Okay, thank you. Yes, evaluating the train model. And first thing that we'll do is we are finding the accuracy score. Finding the accuracy score on training data. So call, write one simple thing called as training data accuracy and call the accuracy score. Now, based on Y train and based on X train prediction, you are supposed to find the accuracy score. So let's see. Let's print it and we'll say accuracy score of training data is nothing but whatever you have written just now, training data accuracy. Let's run it. Okay. Can you see? We have an accuracy score of 0.97. What is the meaning of this? 0.97 is nothing but 97 percentage is our accuracy score. Okay. Same exact thing. If you're getting more than 90%, you can go on to do the same thing as for the testing data as well. So just copy it, whatever you have written for the training data, go and paste it for the testing data model now. Okay. Evaluating for the testing model. And what wherever you can see train, just change that to test. X test prediction. Here also X test num. X testing data accuracy. Here also it is Y test. Here also it is exit text prediction. And finally here. Now let's run it for this. Okay. What is the date? I mean, what is the accuracy score of the testing data now? You can see the testing data accuracy is again 97%. So I told you whenever you are having accuracy score more than 90%, that means our model has been perfectly uh, trained. Otherwise, if you have increased or if you have decreased the training data, separated the values in the form of, let's say, 70 or 30 percentage, then there might be a possibility of getting the lower accuracy score. Because that is the reason I told you accuracy score or basically the training model should be, I mean, training data set should be more than the testing data set. Okay. So you're getting 97 and 97. That means it is a good accuracy score. And we can move on to the last step, that is the prediction. So here we'll make building a predictive system. We'll write something called as input data. Now, this input data should be given by the user. Okay. And it has to be inside the list. This input data, I'll give it later. But this input data, if I give the input data, is the machine is able to understand directly? Okay. For example, if I write hello, how are you? Can the machine is able to understand hello, how are you? No. Again, it is not. So we have to convert into something. What is that? We have to convert into the feature extraction. Where you have written feature. Yes, here. Can you see? We are basically transforming the test data into numeric machine understanding data. So basically, we are calling this feature extraction. So we'll call this feature extraction. We'll write input data number. That means whatever input data is there, that has been converted into a numeric format. So feature extraction will write transform, and we are putting input data inside it. So let's run it. Okay, perfectly running. Now the last step, making the prediction. Now here, first thing that you're going to do is write a variable called as prediction and call the model, that is your logistic regression model, and make use of the predict function. And inside that, you have to predict this, that is input data numeric, right? And let's run the prediction, or basically let's see the output. Okay, it is saying array of 1. Okay, first of all, tell me what is 1 considered as, whether it is a ham or a spam. I'll show you once again. Okay, you can see 1 is considered as a ham email, and whatever I have written just now, is it a ham email? Hello, how are you? Yes, correct. It is a ham email, right? But every time you are not able to understand what is 1 and what is 0. So that is the reason. Let us create one simple if condition where if the prediction is equal to 1, then we can print it as ham email. And if, or basically else, if it is 0, then we can print it as spam email. Let's run it. Okay, you're getting ham email now. Now what I'll do is I'll just change this output. I mean, change the input data. Now here I'll write something called as free, free, free. You have won a lottery, something like this. Okay. Okay, I'll just change. Okay, just by seeing it, can you tell me whether it's a ham or a spam email? Okay, we can consider it as a spam email, right? So let us run it and let's check. Okay, my system is also able to consider it as a spam email. So whatever we have done till now, we have built a system where if you provide any data, or basically if you provide any mail, it is able to convert it as a ham or a spam email. Okay. And let's say important meeting at let's say 7 o'clock, 7 p.m. Now, what do you think about this? It is a ham email, correct? Let's run it and let's run the prediction. Okay, can you see? We are getting a ham email. And if I run it like this, lottery login to check your eligibility. Spam email, let's check. Okay, it is converting into a ham email. Can you see? It is converting into a ham email because it has only one keyword called as lottery. It should have more than that. So what I'll do is I'll write lottery, log in to check your whatever this is there. I'll mention, remove that, and I'll mention lottery. You have won a car. Please sign in. Please click on this link to avail the offer. So let's run it. Okay, can you see now it is being converted into a spam email, right? It should require more features so that it is able to convert into a spam, or it is because generally giving it as a ham email. So whatever we have done till now, if you don't understand, it's completely fine. Don't worry, because we have more and more models so that you can understand it better. What you have to learn is you have to learn these. Okay, you have to learn this. That is the workflow of the scikit-learn. Just see the workflow of the scikit-learn and see whatever we have done in that workflow. And if you don't understand all this, don't worry. While coming to the next class, I'll just remove everything and I'll do it once again. Okay. Yes, there are some different models also, but as of now, I want to teach you the logistic regression model, because logistic regression model, once you understand, only then we can move on to the other models. Otherwise, you'll never understand the other models. So logistic regression is a base. Once you understand the logistic regression, then only we can move on to the other models. Okay. So that's it for today's class. If you have any kinds of doubt, kindly stay back in the meeting, or else we are good to go. Thank you so much, everyone. Have a great night, and we'll see you in tomorrow's class. Thank you. Thank you, everyone. Yes, one second, Manthan.